Hello. This is a lens problem. Specifically, this is one of those problems with two lenses in it. Okay, so we've got an object which is 1.4 centimeters high, so that's the size of the object, is placed 15 centimeters in front of a converging lens with a plus 10 centimeter focal length. 18 centimeters behind the converging lens, there is a second lens with a focal length of plus 12 centimeters. Okay, since the focal length on that one is positive, that's also going to be a converging lens. And we want to find the location of the final image, and we also want to find the size of the final image and find out if it's upright or inverted. Okay? Now, first of all, with these two lens problems, I strongly recommend that the first thing you do is you go ahead and draw out the situation. Okay, and the reason for that is because you're going to need the picture to figure out what the second object distance is. Okay, you'll see that when we get to it. So let's go ahead and sketch this out first. So let's see. There's the axis of my system. I've got let's see. I'm going to have a converging lens here. My object is it's 15 centimeters in front of that. So there's my object, and this is 15 centimeters. My second lens is 18 centimeters behind that, so that's going to be around here somewhere. Okay, where this is 18 centimeters. All right. So that's the geometry of my system. So let's start working on stuff. Okay. Let's see. So 15 centimeters in front of the converging lens. So this is where it's placed. So this is going to be my object distance here. I've got my focal length for the first lens. So I can go ahead and calculate where the image is formed from the first lens. So for the first lens, I can say 1 over P1 plus 1 over Q1 equals 1 over F1. That is 1 over 15 centimeters plus 1 over Q1 is equal to 1 over 10 centimeters. And this gives me Q1 is equal to 30 centimeters. Okay, so let's put that in my diagram. This is going to be the image formed by my first lens here. Okay, and the fact that this is positive tells me that it's going to be on the right side of the lens, the far side of the lens from the original object, and it's going to be 30 centimeters away from the first lens. So let's see, this is 18 centimeters here, so 30 centimeters away is going to be out here somewhere. So let me just put an X there. Okay. This is the image from the first lens. Okay? And now the key to all of these two lens problems is that the image from the first lens is also the object for the second lens. Okay? And so that's going to tell me what P2 is. Now, I got to be careful here. That does not mean that P2 is 30 centimeters. Okay? In other words, the object distance for the second lens is not the image distance for the second lens. It just means that this is my object for this lens. Okay? Now, let's see. This we said is 30 centimeters. And so if this is 18 centimeters, that means that this distance here, okay, from the object of the second lens to the second lens itself is got to be 12 centimeters. Okay? Right? Because this and this have got to add up to that. Now, that means that P2 is actually going to be minus 12 centimeters. And the reason it's negative is because the object is on the opposite side of the lens from my original object. In other words, in as I've been doing in pretty much all the mirror and lens problems, we're sort of working from left to right. Okay, we got our object on the left here, and then our lenses are to the right. And here, our object is to the right of the lens, and that means that the object distance is going to be negative. If the object for this lens was over here somewhere, then P would be positive. Okay? So, let's see. We also know what F2 is. F2 is equal to, let's see, the second lens has a focal length of 12 centimeters. And so I can go ahead and find Q. So 1 over P2 plus 1 over Q2 is equal to 1 over F2. That means 1 over negative 12 centimeters plus 1 over Q2 is equal to 1 over 12 centimeters. And when I work this out, this gives me Q2 is equal to plus 6 centimeters, okay? Which means that my final image is 6 centimeters to the right of the second lens. In other words, it's right about here. All right? Now, so that's the location of the final image. The other thing we said we were going to find was the size of the final image. Okay? And remember, to do that, we need magnification. So the magnification for a two-lens system is just going to, I take the individual magnifications and I multiply them together. So this is going to be minus Q1 over P1 times minus Q2 over P2, which is minus, let's see, 30 over 15 times a minus 6 over negative 12, okay? And when I multiply all that together, notice this is 2, this is 1/2. So I end up with negative 1. Okay? And what that means is that it's the same size as the object, but inverted. Right? Because basically a magnification of 1 means that the image is 1 times as large as the object, and then the minus sign tells me that it's inverted. And that's it.